Have you ever wondered how an app goes from just an idea to something you can actually use on your screen? Well, today we're going to pull back the curtain. We're taking a tour of the digital factory floor to see exactly how modern software gets built and delivered to you, pretty much automatically, and at unbelievable speeds.
So, to really get this, let's start with a powerful idea. Just picture a modern car factory. A sketch becomes a real car that gets assembled, tested, and shipped without a human ever manually carrying it from station to station. It's all automated. Well, a software pipeline? It does exactly that, but for code. And that factory analogy, that's the key to understanding this whole thing.
All right, so every good factory tour starts at the very beginning. Before anything can happen on the assembly line, you need two absolutely critical things: a super detailed blueprint and a manager who's going to oversee the entire operation. Now, in our software factory, the blueprint is what we call the source code. This is it. It's the absolute source of truth. It's the master plan that holds every single instruction for how the application is supposed to look, how it's supposed to feel, and how it functions. So where do we keep this priceless blueprint? I mean, you can't just leave it lying around. That's where a tool called GitHub comes in. Think of it like a super high-tech, secure vault. It doesn't just store the blueprint, it tracks every single change ever made to it, right down to the last comma. It's incredible. Okay, so you've got the plans, but the plans can't build themselves, right? You need a factory manager. You need an automated system that's constantly watching that blueprint vault, and the second a change is approved, it kicks the entire assembly line into motion. And our tireless 24/7 factory manager, that's a tool called Jenkins. It is the central nervous system of our whole operation. Jenkins sees that a new design has been pushed to GitHub, and it basically shouts, "All right, team, we got our new model, let's get to work." And it orchestrates every single step that comes next. Okay, with the blueprint safe and the manager on high alert, let's head out onto the factory floor itself. This is the automated assembly line, where raw materials, our code, get turned into a finished product. The very first stop for our raw code is quality control. I mean, you can't just slap pieces together and hope for the best. You gotta make sure every component is solid, that all the parts fit together, and that the whole thing is built on a solid foundation. This step is what prevents a buggy product from ever reaching you. Now, for a lot of apps out there, especially ones written in a language called Java, this quality control station is run by a tool called Maven. What it does is it takes all that raw code, it assembles all the different pieces, runs a bunch of tests, and then packages it all into a single working unit. It's kind of like building a car engine and making absolutely sure it starts before you even think about putting it in the car. So once our software passes all the quality checks, it's ready for packaging. But listen, this isn't just any old cardboard box. This is a special, high-tech, universal container. And it doesn't just hold the product, it includes the exact environment it needs to run perfectly. All the right tools, the right settings, absolutely everything. And this brings us to the magic of a tool called Docker. Docker is what creates that standardized, portable container. And in doing so, it solves one of the oldest, most annoying problems in software development, the whole, well, it works on my machine problem. With Docker, if it works inside the container, it's going to work anywhere that container can run. Game changer. All right, so our product is built, it's been tested, and it's perfectly packaged. What now? Well, it needs to be stored somewhere safe, and then it needs to be delivered to customers, wherever they are in the world. So let's head over to the warehouse and check out the delivery fleet. Every big factory has to have a warehouse, right? A huge organized space to store all the finished goods, all neatly labeled and versioned, just sitting there, ready to be shipped out at a moment's notice. In our digital factory, that warehouse is called Docker Hub. It's basically a massive public registry. You can think of it like a giant supermarket shelf, where all of our packaged Docker containers, which are called images, are stored. And from here, they can be pulled for delivery anywhere in the world. And now for the final, most critical part, actually getting the product to the user. And we're not talking about one delivery truck here. No. This is a massive, intelligent fleet that can handle millions of deliveries at the same time, manage all the traffic, handle breakdowns, and even add more trucks automatically when things get busy. And that incredible delivery fleet, that is Kubernetes. Kubernetes takes those Docker containers from the warehouse and runs them for real users, out in the real world.
It handles deploying new versions, scaling up when there's a surge in traffic, and automatically recovering if something fails. It's the engine that powers pretty much every big app you use today. So let's put it all together. Let's walk through the complete assembly line one last time. First, a developer writes some code. They push that code to the blueprint vault, GitHub. The factory manager, Jenkins, sees that change and immediately starts the line. Our quality control station, Maven, assembles and tests it. Then the packaging machine, Docker, seals it all up in a universal container. And finally, our delivery fleet, Kubernetes, deploys it and makes it live for you, the user. From a simple idea to live software, all in one automated flow. So, we've just toured this incredible, complex, automated factory, which, of course, brings us to the biggest question of all. Why? Why on earth would anyone go to all this trouble? And the answer is actually really simple. It's the need for speed and for reliability. Just look at the difference here between the old way and the new way. Before all this, a developer might finish their code and then literally email it to an operations engineer. That person would then spend hours manually uploading it, manually restarting things, and just praying nothing would break. And guess what? Things broke, constantly. Today, a developer just pushes their code. The factory takes care of the rest, reliably, every single time. And let's put a number on that pain. The average manual deployment could easily take 4 hours. And that's if everything went perfectly, which, let's be honest, it rarely did. It was slow, it was expensive, and it was unbelievably stressful for everyone involved. And here is the payoff. We go from 4 hours of manual, nerve-wracking work down to under 10 minutes of a completely automated process. That is not just a small improvement. That is a total revolution in how quickly a team can deliver new stuff and fix problems for their users. So why does all this matter? Well, it's about staying competitive. You can ship new features 10 times faster. Your app is way more reliable because the exact same process runs perfectly every single time. You can trace every change that was ever made, and this is a big one, if a bug does slip through, you can instantly roll back to a previous working version in seconds, not hours. That's a lifesaver. Let's just bring it all home. What we've really seen today is the evolution of how software gets made. We've moved from a slow, manual, kind of artisanal craft shop where every piece was handmade and unique to a high-speed, predictable, and incredibly reliable automated factory. And that really leaves us with one final thought. We hear it all the time. Software is eating the world. Well, if that's true, if software is really becoming the backbone of every single industry, then shouldn't we be building it on a world-class assembly line? Thanks so much for joining me today.